Okay, here we go. Um, so anyone should feel free to jump in and ask me a question if you have it. And make sure if you haven't already, I only know only A Block is taking it tomorrow. Some of you other guys have another day, but I did put some extra problems kind of by category up on Canvas that you can look at, including two optimization problems that like Jack, Alex, and Caleb asked in tutorial about extra problems. So I'd put those up. And so I shared those and made solutions to those on Canvas. So you can look at
Thank
it.
you.
I haven't done them, but could we start with one of those optimization problems?
Yeah, how about everyone takes a look at them because I want people to give a shot at looking them. So if you, let me see if I can pull it up here so I can show people what they are just to give you an idea. Hold on one sec. Um, Let me see if I can. Yeah, in the meantime, people feel free to ask something or think of something to ask while I pull these up just to show you kind of that I tried to do. There's also an extra economics problem too, kind of one of those with like the one on the hodgepodge that had uh, the revenue and optimizing revenue problem on there. Okay, so let me see if I can share this with you guys. Back to my Zoom. Okay. All right, give me a second. Let me see if I can do this. Okay, so put it on there. Sorry, I always am sharing my iPad, but I just want to share um, this one screen with you. Hold on. That screen. Why is this not showing up? Oh, here we go. Okay. Here we go. All right, let's see if you guys can see that. Can you see that right here?
Yeah.
Great. So I put two different types up here. One of them is like a fencing problem. Caleb and Alex are featured in it, where it's just a little bit more complicated than what we've done in the past. In fact, this was on either a quiz or test in the past. I try to choose like things that I've put on assessments in the past. And the other kind of tricky part about it is it involves, instead of a number, I'm using just F meters of fencing. So it makes it a little bit more abstract. And the second one is similar to what we did in class with the string and the circle and the square. But this time I'm saying there's a string and you're allocating it to a right triangle and a circle. And other than geometry and remembering some basic geometry, the hard part about these types of problems usually involve kind of the numbers aren't very friendly. So when you do negative b over 2a, you may have to do some cleanup and deal with complex fractions like we did in class. So I want people to have a chance to try them. So if you want to spend this time trying that out, you can. I'm going to give it a little time. And then I'm so happy to, if there are specific questions about either of them, happy to answer them and go through it. But I want to give just people time to at least try them on their own. So in the meantime, okay, Alex had a question about, okay, let's do a domain and range which has a quadratic in the denominator. Okay, let me make something up. So I can't guarantee it's going to be pretty, but all right. So I'm going to stop sharing this. You can find this on Canvas, by the way, the optimization problems, but I'm going to stop sharing so I can share my iPad and show you guys a problem about domain and range. Okay, let's see. Um, nope, via cable. All right, why is that? Hold on one sec. That's not showing up yet. Can you see my iPad yet, anyone, or no? No. Okay, let me try that again. Why is that not showing up? I may have to get a different cord if this isn't. Let me try it one more time. Okay, let me try this. I'm going to try to screen mirror it instead. Oops. All right, let's see. You guys are probably seeing that, right? Let me do a blank screen though. You guys seeing a blank screen in front of you right now?
Yes.
Okay, fabulous. All right, I'm just gonna screen share it instead then. Okay, so find the domain and range. Again, I'm going to make something up and I'm no guarantee on because sometimes I do like to, like you saw in the first quiz, the numbers don't always work out perfectly. So being comfortable with that is important, particularly if you do ICH next year. So let's do f of x equals, I'm actually going to make it even trickier. All right, let's do the square root of, okay, let's do, um, x squared. Um, okay, sorry. Um, minus 6. Um, plus 7. Okay, so it's a little trickier because, well, there's multiple reasons why it's trickier. Totally doable though for you guys. It's the one we've got it something in the denominator, but it's also in a square root. So it's even a step further than what we did on the quiz. So let's give it a minute to think about it. And I'm going to think about it too, since I haven't done it. So on the side over here, I'm going to do it quickly too. Um, So I'll give it another like 2 minutes and then we can start talking about it. Okay, so always start with the domain because especially in quadratic, well, always, but definitely in quadratic problems, it's going to help you inform the range often. So square root is problematic. So I want to make sure -3 over x squared plus 4x minus 6 is greater than or equal to 0. But it actually is never going to be 0 because the only way a fraction is 0 is if the numerator is 0. Okay, so then, a good thing to think about is conceptually understanding what's going on here. So if the numerator is always negative, then in order for this to be positive, and again, it's never going to be 0 because the numerator can't be 0. In order for this to be positive, I'm really looking at where the denominator is negative. In order to do any of this, which is really kind of thinking about sign analysis, I need to figure out where the denominator equals 0. It's not looking factorable. In fact, it's not. So I'm gonna do the quadratic formula to figure out where the denominator equals 0, because that'll help me with kind of my sign analysis here. So using the quadratic formula, -b plus or minus b squared minus 4ac over 2a. So we've got 4 plus or minus the square root of 16 plus 24, or 40. So this is 4 plus or minus 2 root 10 over 2, which is 2 plus or minus root 10. So that's where the denominator is 0. So again, with all quadratics, I think, okay, so those are my x-intercepts of that parabola in the denominator. And I know whatchamacallit, I know that
Miss Jensen,
yeah.
how come you go from -4 to 4?
Yeah, I was also wondering
Oh,
that.
sorry. -4. Sorry.
Okay, okay.
Thank you. Sorry. It's not supposed to be 4. Thank you. Yeah. Stop me if I forget something. Yeah. Sorry. Not -4 to 4. Yeah. Stays -4. Sorry. -2, -2. Thank you. Okay. So the denominator is a parabola that opens up. But remember, because it's in the denominator, it can't be those x-intercepts because that would make the denominator 0. So then I go back to kind of what I'm interested in. If I'm interested in this fraction being positive, then I really need the denominator to be what? Or this parabola to be what?
Negative.
Exactly. So I'm really going to focus on this is what I need. So that's going to inform my domain, which is then going to help inform my range. So my domain, and the one thing to be careful about, again, is just make sure you can't divide by 0. So the domain will be -2 minus root 10 to -2 plus root 10 exclusive. And again, I like to draw this parabola because this will help me with the range. Because when I go to my range, maybe I'll do a different color here. I'm doing the square root of -3. And now looking at what I'm putting into this square root, the low is going to be this point right here, which is going to be the y coordinate of the vertex. So something I still have to find. And the high will get super close to 0. And then I've got the +7. So really, in order to do my range analysis, I just need to find k. And so I go back to the quadratic, and so -b over 2a is going to get me -2, and k will be 4 minus 8 minus 6, or k looks like -10. And so then going back to doing the range analysis, I've got -3 over -10 to as close to 0 as possible, plus 7. And now we just do that out. So the square root of 3/10 is just, if you rationalize root 30 over 10, so root 30 over 10. And then what's -3 over super close to 0, but from the negative side?
Super big positive.
Super big positive, yep. And then I just add 7. So your final range is going to be root 30 over 10 plus 7 to huge. And that's it. So that's just getting a slightly more complex than what we've done on the quiz, I would say.
Miss Jensen,
Yeah.
will you re-explain again why your maximum is like really close to 0?
Why my max? Oh, you mean in this? Let me.
Yeah, in the
this
very
right
beginning.
here?
Yeah.
Oh, because remember our domain was such, because I am doing -3 divided by this parabola, I needed to only put values of the parabola that result in negative outputs. So that meant this was my domain. So anything going into my denominator had a low of k value, and the high was going to be super close to 0.
Okay, so even though it's like a positive parabola, it doesn't matter because
Well, so right, because remember, if I put in anything that has positive y values, you're going to do -3 over a positive, which is impossible because we can't take the square root of a negative.
okay.
And that's why the domain was what it was, right? So we had to do, the denominator had to result in negative values, which is why we restricted it from -2 minus root 10 to -2 plus root 10. Does that make sense, Arya?
Yeah,
have
that makes
a-
more sense. Thank you.
Okay.
Isn't the
How do
range
you get root 30 over 10?
Yeah, oh, yeah.
isn't
Didn't
it
I
root
say
30?
didn't I say root 30? No?
It's 3/10. So
3/10. So wait, let me go back. So wasn't it the square root of 3/10, right? No?
yeah,
Yeah.
And then what I did, that's square root of 3 over square root of 10. And then isn't that root 30 over 10?
yeah.
So if you wanted to leave it like this, that's fine too. I just, depending on the class you're in, some people will say that's leaving a square root
Wait,
in a
Wouldn't we
denominator.
leave it as root 3 over 10, not root 30 over 10? If it's all under the square root?
Root 3 over 10. All right, so if it's all under the square root, so let's go back to
Like
this.
at the bottom, if you were, instead of leaving it as root 30 over 10, if you're leaving it as root 30 over 10.
Oh,
the
sorry,
entire
root
thing.
3 over 10. So yeah. Sorry, not root 30. Sorry, good point.
Okay.
Yes, yeah. Sorry. It's either leaving as this plus 7, sorry, yes, or root 30 over 10. Yeah, sorry, my bad. Yes. You either leave it like this, because I actually don't mind if you leave it like that, so it's fine. Or it is good to get in the habit of rationalizing if it's a number, which is making sure there's no square root number and a square root in a denominator. But I'm fine, at least for now, with it being the square root of 3/10. All right, everyone okay with that? Okay. What do people think if they had a chance to look at those optimizations? Anything you want me to kind of go over there? No worries if you want more time with that, that's totally fine. I mean, you can also hit me up and I'm happy to go over it with anyone who comes to tutorial tomorrow, which is, by the way, before A blocks as well. So
The circle one with the 3, 4, 5 triangle one, that one was hard.
yes, I would say that one's more challenging. I would agree, Orpheus. Do you want me to kind of go over the setup of that?
Yeah.
Okay, so feel free to disengage if you don't want to listen to me with this. But again, since A Block does have this tomorrow, I want to honor them and go over this. Okay. Okay, let's see. Let me open up. All right, so basically the setup here is I'm telling you you've got this 60, just like the string problem we had before. You've got 60 what did I use? Centimeters? Yeah. So I just called one section X, the other 60 minus X. So very similar when we had the 40 centimeter string. But this time I'm saying, okay, we're going to allocate some of this string to a right triangle. And the right triangle just has a ratio of a 3, 4, 5. So you can use any variable you want. I said like 4y, 3y, 5y, just something like that. I didn't want to use X because X is going to be part of the string. And then the other, so this is going to be, I call this A1. The other thing is A2, and that is going to be your circle with, we'll just say radius R. Okay, so you tell me, do you guys want to put X towards the triangle, or do you want to put X towards the circle? Doesn't matter.
Triangle.
Okay, so if we do X towards the triangle, so X, remember, when by putting it towards, I mean the perimeter, or the case of a circle or circumference. So if I'm putting X to the triangle, that means that adding up the different side lengths, that means the relationship between Y and X is 12Y equals X. Right? Just want to make sure people are with me.
Yeah.
Okay. And remember, ultimately, what we want to work with is we want to have an equation, because we want to minimize the sum of the areas. Eventually, this is what I want to get to. I want to get to an equation with one variable that's just adding the two areas together. And that's hopefully a quadratic that opens up. So that's ultimately the goal. So if 12y equals x, if I'm just looking at area of this triangle, remember the area of a triangle is 1/2 base times height. So it's going to be 1/2 4y, 3y. But again, I want to write it in terms of one variable, which is going to be x. So let's just figure out what y is in terms of x. Y is going to be x over 12. So then I can find the area in terms of x. So A1 is going to be 1/2. What is 4y going to be in terms of x?
One third X.
Yeah, so x over 3, or 1/3 x, perfect. And 3y is going to be
1/4 X.
yeah, x over 4. So great. So A1 is just simply x squared over 24, or 1/24 x squared, either way. So that's A1. So S in terms of X, I've got A1. And now let's do the circle. So going kind of back to our picture here, I said for the circle, we're having 60 minus X be the circumference. So 60 minus X is 2 pi R. And remember, for area, we want pi R squared. So let's find R in terms of X. So R is just going to be 60 minus X over 2 pi. And let's just plug that in. So A2 is pi, and then this R that we just have, squared. Okay, so honestly, the rest is just kind of cleanup. So the goal is, with all these types of problems, whether it's a fencing problem or this or economic problem, get it into standard form, ax squared plus bx plus c. So then you can easily find the vertex. or at least the x coordinate of the vertex. Okay, so A2 is, I'll clean this up a little bit. We've got 60 minus x that we're going to squared. And because this squared becomes 4 pi squared, but then I'm multiplying it by pi, it's going to be 4 over 4 pi. So plus 60 minus x, and I'm going to FOIL that out in just a minute. Okay, so that's just A1 plus A2. So first I want to make sure people are following that. Is that okay? Questions on how I got there? So you do have to know a little basic geometry, right triangle and how to find the area, but I feel like you guys do.
Yeah.
Yeah.
So for these types of problems, you're trying to get like the area of whatever shape you're dealing with in terms of x, or
Or in terms of whatever variable you choose. With my string, I chose x, but the goal is always to get whatever equation you're working with in terms of one variable. And because my goal, Alex, in the beginning, it's all about I could have used p, I could have used whatever in my string for my variable. I just chose to use x. Because the goal is to figure out how to cut it, I kind of really want to know what x is in the end. So I do want to get whatever variable you decide on. You want your equation in terms of that variable.
Okay, thank you.
Okay, so again, now let's just do some cleanup. So I've got 1/24 x squared. Let's FOIL out this numerator, which is 60 squared minus 120x plus x squared over 4 pi. And again, remember the goal, ax squared plus bx plus c. So I don't want this common denominator here. I really want to divide 4 pi into everything. Again, so I can find my a, b, and c. So I've got 1 over 24 x squared, 3,600 over 4 pi. Well, 4 goes into 3,600 900 times. So it's just plus 900 over pi. And I'm going to reorder things after I do this. But 4 goes into 120 30. And then 1 over 4 pi x squared. Okay, so let's again get into ax squared plus bx plus c. So let's put the x squareds up front. And the b is, remember, the coefficient with the x. And then the term that has no variable goes at the end, the c value. Because two different things that I really can't I don't want to combine at this point. Are coefficients of x squared. I'm just going to factor out the x squared and write it like this. Just so I can get my a value there. That's my b, and then my c. Okay, so then number 1, I want to check, let's pray it's a parabola that opens up, which it is. This a value is going to be positive, so yay. So when I want to find how to cut it to make a min, then I really am just doing negative b over 2a. And yeah, we are almost there, but for some people, this is the hardest part because it does involve, you're going to have to deal with a complex fraction. So negative b, that's going to make 30 over pi positive, over 2 times 1 over 24 plus 1 over 4 pi. Okay, so this will be 30 over pi, and then 2 I can multiply or distribute through. So 1/12 plus 1 over 2 pi. And now to get rid of the complex fraction, which should I multiply both the numerator and the denominator by?
2 pi?
12 pi.
Let's do 12 pi, right? Because we want the least common denominator, so I want to be able to take care of that 12 as well. So 12 pi over 12 pi. All right, so that gets me, the pi's would cancel in the numerator, and 12 times 30 is 360. And then the denominator, it's actually quite nice. You just get pi plus 6. And that's how you would cut it. So cut such that 360 over pi plus 6 centimeters. What did I say? X goes to the triangle. Yeah. Goes to right triangle. So after a while, once you kind of, yeah, getting the setup is one thing. And then it's really just being comfortable working with numbers that may not be pretty.
What would happen if the parabola was like negative and opened down?
Well, then one, I'd be kind of questioning why I just gave you to find the min. But if that was the case, Parker, then the only way there's a min, so say that is if one of the extremes, meaning you're giving all the string to either the triangle or to the circle. So then you would plug in, if I give 60 to the triangle, what would the area be? And then if I gave 60 to the circle, what would the area be? And whichever is bigger would give you the max. So if I'm asking you for a max, if it opens down and you're pretty confident that you didn't make a mistake, then that means, sorry, if it's wait, did I answer the question right? If I'm asking for a max and it opened up, did I answer your question? Or if you're asking for a min, sorry. If you're asking for a min and opened down, sorry. If I'm asking for a min and it opened down, the one that was opened up was something else we did. But if it asked for a min and it opened down, then yeah, it's either giving one, I would make sure you didn't make an error. 2, it's either all the string goes to one or the other.
Okay.
Because the only way you get them, and by the way, it's not going towards negative infinity. It would be cut off at some point, but it would be the extremes with x either being super high or super low.
Wait, so for optimization problems, we don't ever really use the zeros, do we? It's
No,
mainly
you
vertex
don't.
points.
No, you don't. Unless that's your preferential way to find the vertex, which I wouldn't recommend with optimization problems because usually the numbers aren't that pretty. So finding x-intercepts would be complicated. Yeah. So that's kind of great question because that kind of trips people up. With word problems, they want to set an equation equal to something. But with optimization, it's really, at least with quadratics, it's really about finding the vertex. It's not about finding the zeros.
And then for this problem, like if we wanted to find the total area, we would just take the value that we found, that 360, and then plug that back into our full quadratic.
Yeah, if you wanted to find the total sum of the areas, that was a max. Yes, that's would be what you did. Say you wanted to find, because another question I could have asked here is, so that's how much goes to the triangle. How then would you find how much goes, if that's how much is going to the triangle, how would you find how much then goes of your string goes to the circle?
60 minus that.
Yeah, you just do 60 minus that, exactly, right. And so say someone like Alex in class today, you switch the allocations, you put X towards the circle. And so how I tested if yours was correct is I just did 60 minus what I had gotten to see. Okay, good question. What other questions you guys got for me?
Can we just do more domain and range?
Yeah. Okay, let me. All right, I'm trying to think of something interesting. All right, let's do another. I mean, once we do a little more too, meaning I could give us a couple weeks and by Christmas or winter break, I will have a whole new set of ones we can do. So let me see. Okay, so find domain and range. Um, okay, let me try this instead. So equals 5 minus the square. Oh, no, actually. Let's do square root of s- Okay, try that. And while you try that, I'm going to come up with another one too. I'm going to try to be a little bit more creative. All right, there's a second one too. Give it another couple minutes and then I'll go over these. Okay, how did these feel? Gonna guess good. Okay, let's go over f of x. How would you set up the domain? What do I have to worry about?
Greater than 0.
Greater than 0, right? Not greater than or equal to because it's in the denominator. So negative 2x squared plus 5x plus 7, just greater than 0. I'll be honest, I always try to factor first, and I hate factoring if there's a negative in front, so of the leading term. So I'll take out the negative to see if I can then factor. And what do we think? Was this factorable?
Yeah.
Yeah, I tried to make these so that they were factorable. So 2x and x, and then 7 and 1. So I wanted it negative 7 plus 2. Okay, so it looks like it equals 0 at negative 1 and 7/2. And we don't want it to be equal to 0 in terms of what's part of my domain. It opens down. And so remember, we want the positive. So that's going to be between the two. So my domain will be, and this is for f, domain will be negative 1 exclusive to 7/2. And then kind of back to, hopefully we're seeing a pattern with a lot of these. So how do we do the range now?
You have to find k first.
Yeah, because this is really what I'm looking at. This is the part of the parabola that I'm dealing with. So kind of writing what that means I'm doing 5 minus 3 over, I'm only taking the square root of really close to 0, and the high will be k. So you're going to find negative b over 2a and plug it back in to find k. And is anyone confident in their k value?
5/4.
That's h. I agree with that.
Oh, shoot.
81/8.
81/8. Yeah. So 5/4 is when you do negative b over 2a. Totally agree. But then when you have to plug it back into the parabola to get the k value, and that should be 81/8. So the square root close to 0, 81/8. Okay. So that will be 5 minus 3 over square root of close to 0 is close to 0. What is the square root of 81/8 simplified? Well, you don't rationalize the denominator yet, but 81 comes out as
9 over
Oh.
root 8.
Root 8 or 2 root 2 is root 8. It just makes it a little bit cleaner. Because then when I divide, I'm going to do 5 minus, what's 3 over tiny positive? In other words, what is this going to become?
Infinity.
Yeah, huge, right? And then 5 divided by 9 over 2 root 2 multiplied by the reciprocal. So you should get 6 root 2 over 9. And then we just subtract. So it's going to be negative infinity, and the high will be 5 minus 6 root 2 over 9. So that was your range for that one.
Would you want us to simplify like the 6 root 2 over 9 or
Oh yeah, I should have simplified that to make it, that's true, that to make it, it depends. Sometimes I'll say simplest form. Yeah, I probably should do that. 5 minus, truthfully, I'm not going to probably take off for something like that, but 2 root 2 over 3. But thank you for pointing that out. Yeah. You're going to notice in on the quest, I'm going to have it's not in the domain and range section, but there'll be like a set of problems where you're just solving any method you prefer. But I am saying when you're solving to put in simplest form. So that means if one of your answers is root 8, I want you to give it as 2 root 2, or I want you to simplify the fraction. So I'm going to be I'll be explicit with the directions. Okay. How do we people feel about that? Okay. At least I got one thumbs up. Fab. All right. So g of x, why might why might g of x be tricky? Or what might trip somebody up about g of x?
Because it's like a negative, it's a minus x at the end instead of like a number.
Yes. So pay close attention. Don't think if it's in vertex form, right? So Alex, based on that, really, what should I do before even embarking on this domain and range here? Oops.
Oh, what I did was get it to the ax plus bx, ax squared plus bx plus c form.
Yeah, totally. I would do the same. So it's not in any friendly form right now. So the best thing to do is just kind of FOIL this out and get it into ax squared plus bx plus c form. And what did people get for that when you kind of FOILed it out and combined like terms? Definitely a negative x squared.
Negative x squared plus 4x minus 4.
3x minus 4.
Negative x squared, say that again. Plus
3x
plus 3x minus 4.
Yeah.
Okay. People agree? Because it would be minus 4x when you FOILed it out, but times that negative in front would be plus 4x, but then you have the minus 1, so minus 3x, and then the plus 4. Sorry, then the minus 4, not the plus 4. Okay. All right. So let's look at this. So first thing I always do is I need this to be the case. Greater than 0. And again, I like to take out the negative because I don't want to deal with that. And what do we think? Is it factorable? I guess that's my first question.
No.
Sadly, it looks like it should be, right? If it was plus 3x minus 4, that would be nice, but yes. Okay, so what should we do here?
Find the roots.
Yeah, what's your choice? How would you like to find them?
Quadratic formula.
Yeah, so I'm going to go back to this when it was FOILed out. So negative b plus or minus b squared minus 4 times a times c over, all right, so what do we find in here?
Negative discriminant.
Yes. So what does that mean about all this?
It never touches the
X-axis.
x-axis.
Yeah, so what would you say?
All reals for the domain.
It's a parabola, so it never touches the x-axis. And how does the parabola open?
Down.
Down. Okay, so what would your domain then be?
No solutions.
Yeah, you got it. So be careful about this. This is kind of mean. But do people understand why that's the case? It has no x-intercepts, which you all or many of you said. But the problem is that means it's always negative, which means there's nothing I could take the square root of that would be 0 or positive. So there's no part of the domain. So this, in fact, not only is there no solution, this has no graph, right? So no domain range here.
Wait, but if it's opening down and it doesn't hit the like
X-axis.
x-axis,
Yeah.
couldn't like the vertex just be negative, like, and it'd be under the x-axis?
Yeah, totally. It could, that's what I mean. It probably is under, but can you take the square root of something that only has negative outputs?
Oh.
That's the issue, right? So if I didn't have a square root, 100% you can do this problem. The problem is we're doing the square root of a parabola that opens down. So the only way that has any solutions is if I'm taking the square root of 0 or positive, but if it's always below, then it would never be the case.
Oh, okay.
Yeah, this one was overly mean. And not only was it put in this weird form to start, but also it required you to think about how it opens and the fact that what does that negative discriminant mean in this case, and how does that relate to the fact that it opens down? Whereas if it opened up and you had no discriminant, what would you say your domain was?
All real numbers.
All real numbers, yeah. And this is also going to come into play when we do kind of more higher order polynomials that have like x to the third, x to the fourth. We'll talk about how there's going to be a similar type of situation that goes on under square roots. So yeah, that one was kind of tricky, maybe a little too tricky. But I'm glad the discriminant came out because that's something to keep in mind. Remember, the discriminant tells you the nature and number of roots. Nature being, do I expect square roots in my answer, or would they be rational so that I can factor it? So that's something important to remember. All right, let's do one more problem to close, okay? All right, let me make something up. I like and don't like when I make things up because sometimes it just doesn't work out as I intended. Okay, so let's see. Find a parabola, let's say in standard form. Okay, give me a second to think about. Okay, with axis of symmetry, x equal, well, maybe I'll just do 4. And y-intercept of 6 and an x-intercept of what do I want? Let's do an x-intercept of 8. Okay, so find a parabola with those properties. And eventually you got to put it in standard form, your end answer. So axis of symmetry, and I've given you a y-intercept and an x-intercept. This one ended up being a little bit lamer than I wanted it to be, but that's okay. Any ideas how to start?
I drew like a small graph to visualize everything.
Sure, why not? Yeah. So, because sometimes that can clue you into an easier way. So you've got, the x coordinate of the vertex is at 4. So sometimes, which is what the axis of symmetry is, but I don't know the y value. So maybe I just draw that axis of symmetry. But your x coordinate of the vertex is somewhere along there. And then you've got, it goes through x-intercept, that's a point, 8, 0. And then it goes through y-intercept, 0, 6. Okay, great. Now what?
You can't really have this because it's like on the left it's 4-way and like you want the y to be 6, and on the right it's also 4-way, and so you want the y to be 0 there. And if it's the same distance from the axis of symmetry, then they should be the same y values, and they're not. So there's no parabola that could fit
Yeah,
this.
this ended up being a Miss Jensen fail, but how could we algebraically see what goes on here? How would you algebraically solve this? Because say I'd given you at a different point. How would you go about trying to figure this out?
I would first put what I know in vertex form.
Yeah, so that means f of x equals a, x minus 4 squared plus k, right? Yeah.
Yeah.
All right, so then what would you do? Because I've got 2 points, so what could I do from here?
Find A.
Couldn't I plug in a point for X and Y? So so say I'm just kind of just trying to see what's happening algebraically here. I could plug in either point. Let's plug in 0, 6. If I plug in 0 for X, I would get -4 squared plus K equals 6. So what would that get me?
Wait, how can we solve it if we have two variables?
Well, I'm not going to solve here. I'm going to have an equation with 2 variables. So I'm not going to be able to yet solve for anything. I'm just going to write what this equation is in terms of 2 different variables. So wouldn't this be 16a plus k equals 6?
Yeah.
Okay. Now, if I have another point, f of what's the other point? When I plug in 8, I get what? So a 8 minus 4 squared plus k equals 0. And so I'd get, this is where I knew I was in bad shape, everybody. So once I did this, I was 16a plus k equals 0. People see that? And what's the issue here?
False statement.
Yeah, tell me. Yeah, what will be the false statement here?
Well, like there's no solutions for A and K then.
Yeah,
No.
exactly. Right. Because you've had 2 of the exact same. So say I go to solve for K in the second one, K equals -16a, then I would have 16a, and I plug it into the other, 16a minus 16a equals 6, which is 0 equals 6. Which should have been false. So the idea was not for me to do that, but how about we just quickly pretend that didn't happen, and then we do, let's make it 10. And I just want everyone to try it. And that'll be the last thing. So the x-intercept will be 10. Sorry, that was very stupid of me. I was trying to get it to be nice numbers, but that ended up being horrible. So now see if you could do it. With an x-intercept 10. So the first thing we did, you can keep when we plugged in 0, 6, and now it'll just be. By the way, I would never give you a test with problems that I haven't already worked out because I wouldn't want something like this to happen. But when I'm making stuff on the fly, not always the best. Okay. All right. So plugging in 10. All right. Did people get A equals -3/10?
Yeah.
Great. And so if I have that, then what are you going to use to find K? because that's really the last thing I need before.
Plug in 4 for x.
So we plugged in 4, 4 is our axis of symmetry, right? And so then if I know what K is, if I know what A is, can I plug it back into this relationship between K and A that I found? Because that's my only missing piece, right?
Yeah.
So K is going to be -36 times -3/10. And let's just simplify that. So positive, if I can 5, 18, so 54/5. Just someone give me affirmative just to make sure that someone else got that.
Yeah.
Okay, great. All right, so then putting it all together, I've got f of x equals -3/10 x minus 4 squared plus 54/5. And would you be able to leave it like that?
No, it needs to be in standard form.
Yeah, so I mean, again, this is a little bit of a mean problem if I'm asking you to put it in standard form, but you would have to put it in standard form, it would mean that you'd have to FOIL it out, x squared minus 8x plus 16. You'd FOIL it out, multiply by -3/10, and then add 54/5 to the constant term. And then you'd be done. All right,
Would there be any other way to solve this problem without using vertex form as your equations?
Trying to think what else one would do. So the reason I would jump to vertex form is simply because you know that axis of symmetry, which is the x coordinate of the vertex. So to me that, because you wouldn't have 3, because another way sometimes you can solve is you could, so if, say I wanted, because I know I wanted in standard form, some people like to do unknowns with A, B, and C. The problem is you really need 3 full points. And I only know 2 full points, and I don't know, because I don't know the y coordinate of the vertex. So,
Wait.
yeah.
Couldn't you just state the zeros and then say you have A multiplied by the zeros, and you know that the constant term is 6, so then you know that whatever the constant of the zeros is, you have to, that times A is equal to 6, and then you can solve for A. That's what I did.
Oh, say that again. So you knew that ax squared plus bx plus 6. That's what you knew.
Yeah,
Right.
well, what I did is I know the zeros because it's x minus 10, x plus 2, and then I said A is you're multiplying that by A.
X
then-
minus 10, x plus 2.
Because those are your solutions. And then you know that the constant is 6.
Wait, go back to what? Oh, yeah, that's true. You're right, because you're right. You're totally right, because you know that if you know one, yeah, so if you know, because I gave you an x-intercept, you know the other x-intercept because you know the axis of symmetry.
Yeah.
Yeah, you're right. Yeah, you're right. So I'm thinking if I didn't give you an x-intercept, then it would be harder and you couldn't do this. But yes, you're right. If you know one x-intercept, then you're going to know the other one because it's equidistant away. Right. And so then sorry, go on and say what you were doing.
So you know that the constant here is going to be -20A because
Right. So if
Right.
if you were foiled it out, what would the constant be? Right. -20A.
And then you know that that constant term has to be 6 because you know when x is equal to 0, that y is equal to 6.
Yeah. So you're using root form.
Yeah.
Yeah, and then when you FOIL it out, you know that this is x squared minus 8x. I'm just so people can follow. This is ax squared minus 8ax minus 20a, and you know this has to equal 6.
Yeah, exactly.
And then, so what did you do once you found, so once you found that equals 6, that just gives you what a is.
Yeah, and then you multiply it out with the rest of the
Yeah,
equation. So
that's
you
actually way easier. Yeah.
Wait, if you have root form, couldn't you just plug in like 6 and 0 for your y-intercept and then solve for a using those x and y points?
Yeah, so if you have root form, instead of doing that, couldn't you just plug in the fact that, yes, exactly, which is kind of the same thing, but you're right. Yeah, plugging in 0 because an extra point you have would be 0, 6. Yeah.
Because that's slightly less conceptual, I think.
Yeah, that's less
Plugging in
conceptual.
straight up.
That's just once you have root form, just plugging in a point. Look at you guys go. I was so hung up on when you don't have, when I give you 2 random points, but you're right. If one of the points is an x-intercept, then you totally can find the other x-intercept and do root form. But if they weren't x-intercepts, then just know you could plug in and solve a systems of equations. But yeah, you guys went the better way than I did. Awesome. How we feeling?
I just had a quick question.
Yes.
So since we solved for a and got -3/10,
Yep.
couldn't you just since we know h is 4,
Yep.
couldn't you plug that into -b/2a and then solve for b that way?
Since we know h is 4,
And then you know a as well, so you could maybe.
oh yeah, sure. And then you find so then you can just go back to using vertex form and find the y coordinate of the vertex. Right?
Wait, would you need to still find the y coordinate of the vertex if you could do negative?
Oh, because
b?
then you're just talking about if it's in standard form. Because you know the relationship between a and b, you can just find the coefficient of the b value by doing
Yeah.
negative b. Yeah, you could do that. Sure.
Okay, thank you.
Because then if you know a, then if you already know c is the y-intercept, and then you can use the relationship between a and b by the x coordinate of the vertex. Sure. Yeah, so all different ways. Yeah, I didn't even think about using that. Great. Okay, so I will I'll be around in tutorial, and then for A block, I'll see you guys after lunch. Bye. Have a good night.
Thank you.
Thank you.
Bye, guys.
Good night.
Thank you.
Thank you.
Bye.
Thanks.
Thank you.